So your presenter today is going to be Luis Ramos with Rockwell. He is quite knowledgeable when it comes to networking, and providing color commentary will be myself, Joe Belaschky, one of the automation and network specialists out of Houston, and Brandon Singh from automation and network specialist out of Dallas.
That's about the amount of hair that I currently have too.
I wish my hair was that short. So we do have an event coming up on June 10th through the 19th, Rock Live, which is a completely virtual event this year. And registration is now open, and labs are available, first come, first served. It's going to be a completely virtual event, including keynote speakers and all sorts of labs and training and seminars. So a very, very good event to register and attend, and the link for that is on Rockwell's website, registration. And with that, I think I'll hand it over to Luis to talk about CIP Security.
Sounds good. Yeah, so for anybody that doesn't know me, my name is Luis. I'm a solution consultant with Rockwell, focused on network and security on the cybersecurity front, and also process automation opportunities. Located here in Houston, so I know we got a couple people on the phone call. I'll keep this kind of high level, just kind of talking about, in general, CIP security. We're talking about an Ethernet IP-based security wrapper on what we're normally looking at with control logics, compact logics, and the factory talk family on the Rockwell architecture. A lot of times when we're talking about this, we're looking at what we call the connected enterprise, the ability of being able to tie in what we normally see in the process network, where we're connecting into the I/O, the controllers, redundancy, the different sensors that we have, and connecting that via data connection paths to a business network or maybe an IDMZ. Typically what we would see is like the information technology or the IT world. So that convergence between the two is why we have this conversation. The more we get into newer technologies, the more that you'll start seeing an implementation of Ethernet-based designs, wireless potentially, the request for being able to do remote access, dual networks, and maybe not as much of the serial and the legacy base, but or how to protect the older equipment now that you're introducing all of this new equipment. So what I'll do is have a little bit of a discussion just around just cybersecurity, hygiene, and kind of the general pieces of it. And then as we go through, I'll also implement how we integrate with CIP Security, which is a fairly new implementation method. And yes, to Joe's point, you guys can submit any questions via either chat or directly to the question and answer section. I'll try to do my best to answer them as we go through. If not, we'll make sure to give everybody time at the end of it. And then, as we mentioned, all of this will be recorded, and the presentation material will be posted on the TRC website. So all of it will be available for you going forward. So the first thing I wanted to kind of cover is the type of threat actors that we typically see in the industry. So the first one here is an external threat actor. Usually we refer to this as just a standard hacker. This could be anywhere from a single individual to a nation state actor that is actively looking to penetrate your system. This might be getting into the business network, the IT network, or even down to the controllers, being able to access your HMI, the controllers, potentially wanting to change, modify critical systems that you have, or potentially even copying the equipment or the industrial, your IP that you have. The other type of actor, which is something that we refer to as the human error perspective, is this almost takes up more than what a hacker would be. So what we'll usually see, this is accidental infections, accidental downloads, somebody picking up a USB drive and plugging it in that had a virus, somebody accidentally going on a controller that they weren't supposed to. So if anybody's ever had somebody go online with a controller, connect into a compact or control logics only to realize that they were connecting to the wrong one because there was no segregation, they were able to go directly into a controller and potentially turn on a pump that they weren't actually looking at. So a lot of the times line of sight becomes an issue here. So human error does take into perspective some of the threats that we need to mitigate against. And then the other one that we'll look at here is insider threat. Insider threat is either somebody that generally we consider it as a disgruntled worker, somebody that either has started, has been fired, or potentially is still working for the organization, and they have direct access to be able to get in. So this is a malicious actor that will be able to gain access. Normally, in this case, it's not coming from the business network side. This is directly connected to the panel itself. So in these cases, every single one of these type of threat actors is able to get inside of the access, whether we're looking at the business network side, inside of the your own INE laptops, or potentially inside of the panels. And at which point, once they're in the system, the other piece that we have to protect against is being able to pivot from one location to another. So being able to get from one panel to another, from the business network down to the OT layer. Things that we're mitigating against: unscheduled downtime, stolen intellectual property. That's the big one in most cases. So again, this is just a reference on some of the threat types that we're looking at. The other piece that we want to talk about is the type of attacks that we have to protect against. So as we start looking at this, the first one here is a reconnaissance attack. In most cases, what we're looking at here is more of what you would consider a direct attack. Somebody plugs into the system, either via a network switch or directly into the controller. And at that point, they're able to copy or look at the information. This might be just a monitor type attack. They want to be able to see what you're looking at, or potentially this could be, again, stealing intellectual property. So in this case, we're calling it loss of confidentiality. A man-in-the-middle attack, probably something you guys have heard multiple times in different meeting representations. CIP data here, this is your Ethernet IP packet that you're sending information back and forward over the wire. This could be from a workstation to a Rockwell controller, or from controller to controller. The man-in-the-middle attack here is essentially being able to intercept that information and either copy or monitor it without the controllers or the users being aware of that. And another concern here is, instead of just copying the data, is potentially manipulating that data to mean something else. So a lot of the times what we might see in these critical infrastructure locations in the industry is they can make the system look like there's no alarms when realistically everything, all the pressure valves and everything are going out of whack. So the final one that we typically see, this especially on the ICS certs, a lot of it is the DOS, denial of service. So typically what we see here is a large amount of packets that are sent directly to a single port with the intention of knocking it down. So if you have enough, sometimes you'll refer to it as a broadcast storm. If you see enough data coming through, the port will shut down. At that point, the conversation that you'll have from the workstation to the controller, or direct controller to controller, will be blocked because the port will be completely down. To take a quick step back, one of the things that we'll usually see in the cybersecurity space for industrial automation is the compliance and some of the standards. Rockwell has aligned heavily with ISAIEC 62443. So this gives you the ability of being able to do a very defined prescriptive method of cybersecurity for the entire architecture, inclusive of servers, the networking, and the controllers that are put forth. So I'll go through a little bit more detail since we are aligned with 62443. CIP Security is part of that alignment. So we heavily cater to that as one of the main options. NIST 800 is another standard for securing the IACS. We'll usually use this in terms of being able to support the actual physical hardware and software that we're tying into. We use that as part of the NIST cybersecurity framework. That's a document that provides guidelines for the entire organization. So when we start looking at how the system should be put in place, when we're looking at detecting, mitigating issues, we use that as a overall holistic approach. And the other thing that you guys should be aware of is ICS CERT. So this is the industrial control system. You'll probably see in this little Homeland Security designation. Anytime there is any issues that are found in the cybersecurity space, they are the ones that are alerted. They will send you emails, and then we will also send out security advisory index forms that are tied to this in our knowledge base. One of the major approaches that we layer on top of everything, including the 62443, is we start talking about defense in depth. It doesn't necessarily matter what specific policy, what specific type of certification body that you're addressing. In almost all cases, you're looking at some type of defense in depth strategy. Hold on. There we go. Got to get that cough out. So when we start looking at this, a lot of this is referred to as the security onion. So we'll start looking at the different methods of implementing security. This is the same guidelines that we potentially do when it comes to a process safety type system, where we want to do multiple layers of defense against a risk analysis that we'll put forth on a process system. When we're talking about it from a cybersecurity front, we want to layer multiple levels of security, not only at the device level where we harden the system, the authentication to be able to access that system on the application side, the cybersecurity hygiene that goes into the computers, the servers, the workstations regarding patch management, antivirus, the ability of being able to do whitelisting to make sure who's able to talk between what, looking at the overall network architecture and how we would handle the managed switches and doing the access control list and being able to mitigate and learn against the MAC addresses. The physical layer, so a lot of this, we usually just completely forget about the fact that we can introduce a gated system. So we can put a lock on a panel, we can put key lockouts on your managed switch from a physical point of view to kind of encourage somebody to walk away in case they see that. And then obviously the policies, procedures. So this is the operator point, the human element when we start looking at this. Just how do we train the personnel on the industrial security side? Going a little bit into detail on the IEC 62443. Again, it's a series of standards that were written. They are international. They're broken up into 4 main sections so that you see the general policies and procedures, systems, and product. So we will be focused on the system side of it, but the general, just to give you guys a representation, a lot of this is based off the guidelines and almost think of it as a dictionary. It's giving you a representation of what the system means, how it is put together. All of the acronyms and everything that you'll see in cybersecurity are all listed under general. The policies and procedures put together a guideline on how something should be implemented, what guidelines should be done when it comes to patch management, user authentication, the methods in which you would do your network assessment, your inventory solutions. All of that are regulated as part of the policy and procedure side of it. The system level is where we get prescriptive on telling individuals how a system should be put together based on the foundational requirements or fundamental requirements, and also the security levels in mind on how much risk is mitigated when it comes to setting up these systems. The product level, really quick, is mainly for vendors. So from a Rockwell perspective, we subscribe to 4-1 and 4-2. to be able to harden the equipment, and also how we go about engineering the equipment so that we know that we're cyber secured, both from a deployment and delivery arm, and also the physical hardening of the equipment, so that when we put that in place for a 3-3 type cyber secure system, we're using technologies and processes that were part of the guideline. So this is just another way of being able to see that. With CIP Security, which is kind of the main discussion for this topic, is we'll be looking at 3-2 and 3-3. So the system design and also the security requirements and security levels. This sits in place of, in CIP Security, because it is a wrapper around the existing Ethernet IP infrastructure that we'll put in place. It is very detailed from a level 3 down, connecting into your servers, the control logics and controller system, and then typically the IO and the networking that goes in between. From a cybersecurity framework, one of the things that you guys should just be aware of on the Rockwell side, so the 62443 4-1 that I talked about, this is where we start looking at the development of the physical hardware. So one quick note is the L8, the ControlLogix 5580 controller, does have the certification for 4-1. This is something that you can download directly off of our website. And if you have any conversations on that, we could put together a system. So just be aware of that. The 4-2, as I mentioned, is how we would handle the entire selection product of the development cycle. And then one of the big things that are going to be coming out soon is we do have a white paper in the process side. So Plant PX is part of our DCS package. We have a small white paper that exists now on how we would implement a Plant PX system using the 62443 guidelines. We will have a full application and system reference architecture as part of the Plant PX 5.0 architecture that we'll be putting out later this year. So just be aware of that. On the right is an example of our security framework. So we'll see that as part of the CPWE, the Converged Plant-Wide Ethernet Design Guides. So we'll be referencing that as we go forth as well. Before I jump completely into CIP Security, I just wanted to give a quick note here. So some of the things that we do on the IACS, so the Industrial Automation Control System, some of the things that we occasionally forget is from a physical side of it. Again, locking down the control panels, the locks, video surveillance, authentication metrics for two-factor authentication, and then even just port blockers. And then one of the things that we'll usually see from a compact Logix or control Logix is you have the ability of locking down what people are able to access. So from all of the control tags that are inside of the controller, you always have the ability to block external access. So you have a read-write, read-only, and none ability inside of the controller inherently that just has to be turned on. And you also have secure slot ability and change detections for a security hash, and then also the ability of defining a security authority. This is without implementing anything regarding CIP security or anything else. It's all part of factory talk security down to the controller level. And then the last thing I'll mention is the key switch that's always in the front of your controller has 3 positions. The run and remote are typically the ones that you want to look at. If at some point you do want to lock down your controller so that nobody is able to access it remotely, the best thing to do is move your switch into run, remove the key, and at that point, no one has access to be able to make any modifications, go online, or change anything. Now, I'll be honest, I have a remote on the TV for a reason. I like to put in a remote because I don't have to go directly to the controller. But as we start looking at the risk involved and the assessments that you need to do on the networking side, that might be something that's very low-hanging fruit that can easily be achieved without having to implement a lot of the upper-end networking pieces. And like I said, This is probably going to be a lot of information, but as you guys have questions, feel free to drop them into chat or on the question side of it. We'll make sure to get to it. I keep saying CIP Security. I want to take a little bit of time just to introduce a little bit more on what it is. So for anybody that hasn't heard CIP before, it's Common Industrial Protocol. That is the protocol that we use through the wire. So that's the ability that we have to connect directly from I/O to controllers to software. The Ethernet IP is essentially a wrapper around the CIP or Common Industrial Protocol using standard Ethernet practice. It's part of ODVA. So Ethernet IP, Common Industrial Protocol, and also CIP Security is part of the ODVA standard. It's a separate third party. So Rockwell itself doesn't specifically own ODVA or Ethernet IP. We created it, ODVA manages it. That's why multiple different vendors have access to Ethernet IP in their systems. What CIP Security is a security extension, so a wrapper around CIP itself. So typically what we'll see here is it's a transport layer security and also datagram transport layer security, so TLS and DTLS. That puts a wrapper around it. So for anybody that has seen I/O traffic or communication to the HMI, you'll usually hear us refer to class 1 messaging or class 3 messaging. This is taking over with that. So you would put a wrapper around it. It is very similar to the information when we start talking about CIP motion, CIP safety, CIP sync. One example is if you want to be able to do a kind of synchronization between your controllers, your servers, and let's say your switches on a time scale, you can use that for your PTP and your NTP. CIP Security or CIP Sync in that case is, again, just a wrapper around the Ethernet IP protocol to be able to provide you that precision time protocol. In this case, TLS and DTLS is very similar to anybody that's ever gone to a web page. You go, and if you see this little lock on the web page and you see HTTPS, it's the difference between a non-secure web page and a secure web page using a standard HTTP, which uses TCP/IP port 80, to looking at the secure HTTP. At that point, you're now on port 443. Same thing here, CIP Security using the TLS and DTLS. Instead of using the standard TCP/IP ports that you see at 44818 for Rockwell or the 2222, you're now using 2221. So that going very deep dive in that side of it, but I'm including this in the slide just so you guys can see it from an Ethernet IP profile. So when we're looking at CIP Security, we're looking at the device identity, authentication, integrity, and the confidentiality. So we are able to use digital certificates. You're able to do a pre-shared key between different controller units. The device authentication is handled again via TLS and DTLS. The data integrity is a key mesh or key hash message, HMAC for short. So you'll see that being able to kind of do your data integrity between the different systems. And then the confidentiality is the ability of being able to do encryption from controller to controller. So this is something as a feature set that's turned on using the system for CIP Security because it's part of the protocol. That being said, one of the things that you'll see is for us to be able to implement CIP Security, it would be part and tied to specific hardware platforms, and then we would also put wrappers around legacy products. But for anybody that's listening, essentially what we'd end up doing is for CIP Security, we support the L8 controllers, so version 32 and above. So that provides the ability of being able to do the CIP Security directly on the device. We also will use the ControlLogix EN4TR. So this is the Ethernet IP adapter that came out early last year. So this would be used in place of, let's say you're using a ControlLogix L7 instead of an L8, but you still want to be able to do secure communication between that chassis and let's say another L8. or even the FactoryTalk Services platform, I can introduce an EN4TR in with the L7 chassis and have that secure communication. The system or the graphical GUI that provides that central policy management is called FactoryTalk Policy Manager. It is part of the services platform. It would be installed the same location you would install your FactoryTalk directory. And then you'd be using FactoryTalk links 6.1 or higher, and the rest of the FactoryTalk services platform. This is the same thing that runs Studio 5000, FactoryTalk Asset Center, FactoryTalk View. All of that is built off our FactoryTalk services platform. So as we start seeing it, that's what enables all of this equipment. And then some of the quick use cases, just so you guys are aware, when we're introducing CIP Security, some of the reasoning behind that is the ability of being able to do, like it says there, a centralized policy management or centralized system management. Because of the graphical interface, this allows you to set up all of your devices and all of the security paths that you're doing in one centralized spot. Micro segmentation. So in the next slide, we'll kind of show what the differences are between a zone and a conduit. But a lot of the times during standard networking discussions, we're talking about the ability of being able to do VLANing, segmentation, separating out traffic from IO to HMI traffic. This goes a step further, and you're able to designate specified zones to be able to say, okay, this communication is allowed between this controller, but not allowed to this controller, or this workstation is not allowed to talk to this other controller here. That's the idea of that micro-segmentation. On a low-hanging fruit idea, you can also disable HTTP ports. If part of your security policy or cybersecurity policy is to not enable any web pages from our controllers, from our devices. Most of you are aware that most of our Ethernet IP devices, anything that has an Ethernet port on it, typically has a web page that has diagnostics associated to it. So this is a quick graphical interface that you can access via Chrome. If you wanted to turn that off, the easiest thing is just to disable that as part of CIP Security. And then we also have the ability to support some legacy systems. So we can create what's called a trusted IP conduit to older equipment so that we almost to the extent of doing an access control list between controllers to a legacy system. One of the things that we will see in the future is coming out right now. We're set to ETA around October of this year. We're going to introduce a CIP security proxy. So that's this guy right here. So this will give us a single network connection into a legacy piece of equipment. Obviously, basically, if the device did not support CIP security natively, so again, we're talking about the EN4TR, the L8. If we're looking at the PowerFlex drive, the IO format there, this would allow that secure communication down to that level. So from the controller to the IO, that would be a secure communication. And you can enable and disable the authentication, confidentiality, or integrity, depending on which one you're looking at. So that'll be something that will provide more information as we get closer. Like I said, right now we're looking at October. As part of 62443, and as we start looking at how we do the assessments, one of the big first steps that you do in providing a cybersecure system is defining your zones and conduits. So a zone here is a security zone for a logical grouping that could be physical, application-based, common assets in a location that have the same security requirements. So the easiest conversation that I can usually have with, regarding the definition around zones is looking at your BPCS or your DCS versus your SIS system, so your safety system versus your process system. In most cases, everybody understands that that's separate hardware, separate groups. In this case, we would put them in separate zones. They have different requirements on who has access. They have different requirements on what kind of logging and documentation are required. So we would put these in their own individualized zones, And then conduits are the logical grouping of communication or channels between the zones. So this could be at the network layer of a managed switch, and it'd be an uplink to an access switch to a core switch or a distribution switch, or it could be a shared requirement from peer-to-peer communication that we might have. So we'll reference this a little bit when it comes to 62443. The reason why you would define this early on in the 62443 kind of life cycle piece of it is when you're looking at it, if you don't know your zones, if you don't know your conduits or what the requirements are, it's hard to mitigate your risk levels when you start putting together a system. You have to understand where the data is going and how it's going to get there. So this is going to be an eye chart. If everybody is like me and you're just sitting in front of a computer now, this will be a little bit easier to kind of ingest. But I'm going to provide a couple of examples of why we would want to provide CIP security. So again, Common Industrial Protocol or the Ethernet IP. Just to give you a little bit of overview. So what we start seeing here is the different colors here are the different security zones. So this is a kind of exaggerated example, let's say, of what a system would be. But as you start seeing it, we start talking about using the policy manager to be able to incorporate your zone to zone conduits, how we would go from the operation or the control room to the individualized zones that are there on the ops, the different cell areas that we're putting in. Each one of these boxes could represent a different panel or a different building, with the network infrastructure using either managed switches, device lower ring, redundant star, PRP infrastructures, all of that coming back to maybe a virtualized server stack that you might have in with all of the network manager, factory talk view, the HMIs, panel views, all of those different pieces. The properties that are defined inside of CIP security, we start looking at certificates. So factory talk, the directory along with the policy manager becomes a certificate authority. So we can define certificates between the CIP secure enabled devices, the data integrity piece. So when we start doing that HMAC algorithm to be able to do that, and then also the data encryption. If we needed to go a step further and go through and encrypt the data from one point to another. So again, this might be a complicated example, but I'm going through a couple of examples just so you guys can see the use cases. And if you guys want to have discussions on them or questions on it, please feel free. The first example will be looking at limiting device connectivity to, in this case, an untrusted laptop. So in most cases, a lot of times we have to deal with a vendor that comes in, a contract worker. They plug in directly into a ControlLogix chassis. So obviously you can set up properties inside of the controller to be able to enable or disable the ability of being able to go online or see something. But one of the things that inside of CIP security, because of the fact that you're setting up your different zones and conduits, is you can now say, okay, this is an untrusted computer, and that untrusted computer has no access to be able to go to another zone. So one of the examples that we usually use in our systems is CIP bridging. The ability of being able to go out one Ethernet module down to another Ethernet module and then bridge through and find different panels underneath. So in that ability, what this is doing is blocking a person from being able to go through and browse the rest of this system if they connected directly into this EN4TR or another EN2T that might be on that network. This is tied in with FactoryTalk Link's browser. So anything that you do at the zone and conduit with Policy Manager is implemented down to the FactoryTalk Link's browser. So one quick representation, if you see this little green shield on it, the green shield means that security is enabled through CIP security. If it's grayed out, which is the default, it has the ability of using CIP security, but it's not turned on. So just again, in this example, what we're showing here is somebody trying to get through the backplane, show the equipment that's down at a different level and being blocked from scanning out past that. The second example that I'll be talking about is an accidental download, or realistically, in most cases, a blocked download attempt. So again, somebody goes onto the network, let's say, and given my example earlier about the line of sight, if you want to have a requirement so that someone that uses a laptop within a specific zone only has access to the equipment within that trusted zone, let's say if for some reason they manage to get on the network and they scan the LA controller that's on a different VLAN or a different network scan, with the policies that you put in place from zone to zone, you can now define who has access to go online and offline based on the zone attributed to them. So you can do this from a FactoryTalk security platform where you're doing it by the user, but this is also allowing you to do it by the zone. So if they're connected directly to the panel or to the switch in that location, they don't have access to control anything outside of that, let's say, building or cabinet based on the security policies that you put in place. At this point, it doesn't matter who the user is, you're actually authenticating against almost an access control list on that switch. The other example that I have here is essentially looking at your data integrity. So if somebody goes in, connects to the data, this is attempting to alter the information. So again, that man in the middle attack that we talked about at the early on, if somebody is able to get the information out of a controller and essentially put themselves in between the controller talking to IO or controller talking to another controller, whether that's producer, consumer or not, one of the things that we want to protect against is someone not able to grab that information and modify it and say that a system is not an alarm or that the set point is higher than it currently is. So all of that information is stuff that we want to protect against. Again, depending on how we set up our zones and our conduits and that authentication side of it, we're able to turn on the data integrity and potentially even the data confidentiality if we wanted to go that route, to be able to prevent somebody from altering or modifying, manipulating the data. If we do want to take that extra step and look at the data confidentiality or the encryption side of it, this is again where we start looking at being able to protect your IP. So the secret sauce that goes inside of the controller to be able to have something utilized. If you want to prevent information that's going through the wire, passwords, in the AOI instructions or the different data sets from a PID block, all of this would be incorporated in here so that not only are you making sure that the data going from one spot to another hasn't been altered, but you also want to encrypt the information so that if somebody is on the network, they're not able to copy or see any of that information. So that protects you, again, in terms of the encryption side of it. So if we go, again, just to talk about data integrity and also data confidentiality a little bit more, the example here is from a FactoryTalk server. So again, FactoryTalk links communicating through, you want to write a command into the control logics. What that does is it puts a shared session key from the individualized server that's using CIP Security, communicates that with and puts a algorithm, that shared key on the actual write command. As it goes through, goes over the wire, gets to the L8. At that point, once it gets to the L8, what we start seeing is that has the shared key as well. So it will take that, put the information against that shared key. And essentially, it's a lock. So it's a key mechanism that they do. As long as both the incoming and outgoing pieces have that shared key, you now know that that hasn't been changed or hasn't been manipulated. So at least you know at that level that the information is correct. Nobody's been able to access it or nobody's changed it. Very similar idea to if anybody's ever seen the little hex code that gets generated in the controller when you change the key location. So there's an ability of being able to do a little hex string as kind of your golden batch ability of when you do your commissioning, that nobody's modified the code whether that's down to just changing the key position or changing any of the code inside of the controller. Very similar idea, but now it's not just the controller itself. We're talking about sending data over the wire and moving traffic. So this might be going through a switch. This might be direct connection via the Ethernet run. The other ability here is data confidentiality. So again, in this case, same idea. We have the shared message key. We're putting this together, but now we want to also be able to encrypt the data so that if anybody is able to grab it, they won't be able to do anything with it because they don't have that encryption method. So this now takes that same idea, takes it a step further so that you're protecting not only to verify your integrity from point to point, but also looking at the confidentiality of that data stream between your FactoryTalk Services platform and your ControlLogix platform. Or like I said, you can also implement this from controller to controller level. The last slide that I have here, just to kind of refer to this was extremely high level. I'm not going into a lot of detail on implementation, but one of the things that I wanted to cover here is, so when we start looking at the overall holistic approach when it comes to security, it's not a one and done. A lot of this is based off of defense in depth. So as we start looking at this, the CIP security falls in line when it comes to the controllers, the IO, and the servers that go with it. Layered on top of that, we would use this as part of the FactoryTalk Services platform. So again, I mentioned Studio 5000, FactoryTalk Asset Center, FactoryTalk View. So we also have the ability of being able to do FactoryTalk security in those aspects. So in CIP security, we have the ability of being able to do the trusted IP conduits, whitelisting, point-to-point solutions with anything that supports CIP security. And then using Asset Center, we're able to do an asset inventory, or detect any tampering within the controllers. And the Studio 5000 has the ability of creating policies on who's able to incorporate, go online, download to a controller. And then if we're looking at server to server communication, we have the ability of being able to implement IPsec. So this is something, again, fairly new from us, to be able to do an IPsec tunnel between the FactoryTalk Services platform, so from client server implementations. And then looking at a broader scope, even if we're looking at a non-Rockwellized system, a lot of times we'll have different third-party components all throughout, incorporation of border devices like firewalls and different abilities within the switches for access control list. We also have the ability of being able to do third-party gateways. So if anybody's ever seen FactoryTalk Link's gateway or the OPC UA connector that we have inherent as part of the services platform, we're able to incorporate OPC UA security if we're looking at uplink data that's going out. So I say all of that just to say we have a lot of different solutions within cybersecurity, including the white papers that are coming out. So one of the things that you guys want to be aware of is if you do have questions on implementing a system, reach out to TRC, reach out to myself to have that discussion on what makes sense for the level of risk that's part of your system. That's my little disclaimer. I'll turn it over to Joe for a couple extra pieces.
Thank you, Luis. That was very insightful. Rockwell has put together some different documents that we can use to reference, and one of them is the CIP Security Design Guide. And it's a very in-depth document talking about all of the different functionality and stuff. So portions of this manual are referenced in the presentation today. It goes into a lot more depth, a little bit more dry, not quite as an exhilarating read as something like maybe Harry Potter, but a very, very good manual. Rockwell's put together an entire suite of these, actually. So within this one, you can see the breakdown on the right of all of the different sections within it. And so deep, it goes quite deep into all of the different pieces, including testing that was done. So, and next slide. Rockwell has put together additional documents. So we have a few on CIP Security, but also stuff beyond just regular CIP Security. So we've got the CIP Security application techniques, but we also have just some system security design guidelines, and then using FactoryTalk Policy Manager to implement some of the security functions. So, and these are all specifically about security. We have a whole stack of them going over CPWE and some of the other network architectures and other portions of just networking in general, in the way that you would set things up and how best to implement each of these platforms. Rockwell also has a team that we work with very closely to do assessments on security. So we have the capability of working with Rockwell, bringing in Rockwell and working with you directly, and bringing in different network assessments. I particularly like this slide, mostly because of what's written on the whiteboard. That's typically about how I would do a login process. But Rockwell does have network assessment on the risk side. So specifically within that 62443, they're very knowledgeable about that, the standard, the implementation, and it's a holistic approach. So one of the most important things when we're talking about network security is looking at the holistic solution on everything from the beginning through to the end, on where your different access points, who's going to be using it, where they're going to be using it, how everybody needs to be able to work around within the system, making it secure but not too difficult to use, and balancing all of those together. And so we kind of work with Rockwell to get different security and risk assessments, and even ones that aren't as deep as the 62443, just a basic understanding of where you're at today and how that compares to what's available. So please reach out to us, and Luis, myself, Brandon, all of our different Reynolds and Rockwell resources are here to help you with those needs. And with that, I think we're done. Let's see if we have any questions.
Yeah, like Joe said, essentially we'd be looking at this as a CIP security is very defined in what we're able to implement, and a lot of it is an Ethernet-based system. But as we start looking at it, and you guys have any questions regarding third-party connections or just standard products that we have, how do we support security when it comes to compact logics, our static switches, how do we implement firewalls? If you guys have questions, feel free to ask. It doesn't have to be specific to CIP security, especially when it comes to those assessments. The first stage is usually understanding what you have on your network. And if you don't have everything documented, or at least some type of spreadsheet that tells you what controllers, firmware, serial number, things of that nature, that's usually step one. And we can help with that. We have tools in place to be able to do that pretty easily. But yeah, if anybody has any questions, either feel free to text them in, or I don't know if in this one you can raise your hand type thing. We got a couple of panelists on here. We'll figure it out. Is ProSoft working with Rockwell to improve? I'm assuming you mean cybersecurity on that one? ProSoft is working with us. So we have a couple of methods of being able to implement their system. I don't want to necessarily say securely, but one of the things that we typically see is communication between controller and IO is not something that we inherently add security to. Sometimes there's a requirement, but a lot of the times when you incorporate some of the, like take CIP security, for example, if we implement CIP security to the finite level of putting in encryption, you potentially have a performance hit. So we typically don't see that for either motion applications or some of the critical infrastructure. So as part of 62443 and the different engagements that we have, ProSoft and other gateways fall into a realm where we promote an ability of being able to kind of secure that communication up for the, so yeah, so we would use that, kind of segregate the traffic so that we're not on the same traffic that we'd see for Ethernet IP or the same as the IO. In terms of the other question there is it possible to implement TLS or DTLS on a Modbus TCP IP? In that case, occasionally what we do, because of its OPC nature, is we might move that over to an OPC UA. So and that does similar idea of what we're doing with Ethernet IP on CIP. The other piece to it is if the data comes into our Rockwell controller, at that point, if we're looking at the L8 or the EN4TR, at that level, it's now part of the CIP security, or we can do that as part of our system with the TLS, DTLS. So it'd be looking at how do we minimize the Modbus or even legacy data communication side to an isolated section of the larger system. Hopefully that answered that question. Anyone else have any questions? So just as mentioned, this is recorded, so we'll have it up on the Reynolds Company website. We will share the presentation, so everything is public knowledge. For anybody that's logging in or registering to Rock Live, there'll be deeper dives specifically around CIP security and also other cybersecurity implementations with that CPWE, the Converged Plant-Wide Ethernet guides. So any questions you have or anything that comes up, please feel free to reach out to anybody at TRC. And again, feel free to reach out to me if anybody is interested in a deeper conversation. I'm happy to do this. At this point, it's webinar, so we're all, I'm sitting in my office looking for something. So last question that came in. Have you any case or example of cybersecurity implementation with Rockwell and Wonderware? Interesting. Not specifically. I haven't seen anything regarding from a cybersecurity front. They access our equipment the same way, but because of the fact that they're not using the FactoryTalk Services platform, we would not be able to establish the secure connection to them. They'd still be going through a back channel. Now, there is abilities of being able to set up either firewalls, or what you will usually see is a firewall that has the ability of being able to do the kind of an Ethernet IP and Modbus detection. So in the IDS, or the intrusion detection system. So at that level, then you can make sure that you're only sending the read commands from the controller. Exactly, yeah. Now, I would argue that we try to swap out the Wonderware, but that's just me. But yeah, reach out to me. That might be an interesting case that we can look into. Sounds good. Well, I appreciate it, guys. Again, thank you for joining. You guys have anything else to say on your end?
Thank you. Thanks for coming. We'll see you next month, and we've got a whole bunch of tech sessions coming up. So please register and join.
Appreciate it. You guys take care.
Thank you.